Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about the planet Mercury. So our first stop among the planets in the solar system that we will be looking at, other than Earth, which of course we have already gone into some detail on. So let's go ahead and start and see what we have learned about Mercury. Mercury, here are some of the numbers for it. It has an orbital period of 88 days. It is the closest planet to the sun and whips around there pretty quick. Its semi-major axis is about 0.39 AUs. So a lot closer to the sun than Earth. Its diameter is a little more than a third of the Earth's diameter. So it's a little bit bigger than our own moon. However, the density is far greater. Density is closer to that of Earth. Now remember, it's close to the sun. It would have formed from more metallic material, and that would give it a higher density. It has a eccentricity of zero point 0.2, the largest eccentricity among the planets in the solar system. So it has a very elliptical orbit, meaning sometimes it's close to the sun and sometimes it's further away, much more so than Earth. And its rotational period, how long it takes to spin on its axis, would be 59 Earth days. So let's look a little bit about what we know about, say, the interior of Mercury. What is the interior like? Well, we've never explored the interior of Mercury any more than we have explored the interior of Earth. And we never landed on Mercury to explore the surface, so we can't even use things like seismic waves. However, we can use some other methods to be able to determine that Mercury has a very large core and a much thinner mantle than Earth. Now that might be expected because it's so close to the sun. We'd expect more metallic material and a larger core in that case. The core is actually about 70% of the diameter. So really, Mercury is a large ball of iron and nickel. Now we also know that it is partially molten. How do we know this? Well, Mercury has a weak magnetic field, so not a powerful magnetic field like Earth. However, it does have some magnetic field, meaning that part of this core in the central part of this must be molten to generate that magnetic field. Now, when we look at Mercury, Mercury rotates a little bit different than other planets that we know, although we'll see similarities when we get to some of the moons. Until the 1960s, it was thought that Mercury kept one face toward the sun. Interestingly, this would have made it the hottest and the coldest planet in the solar system, with one side constantly facing the sun and being baked, and the other side never seeing sunlight and being incredibly cold. However, radar observations showed that this was different. And we found that the rotational period of 59 days was 2/3 of the revolution period of 88 days. Now, just to get the terminology here, the rotation is the movement of a planet around its own axis. That on Earth is the day. The revolution is the movement of an object around another. That would be the orbit of the planet around the sun. So what this means is that there is a resonance here, that every two rotational periods matches 3 days. And we can see in the animation here, if we pick out a point where the arrow is pointing toward the sun, such as we had right there, then the next time around it's pointing away. And then coming around this third time, it's pointing back to the sun again. So 3 rotations becomes 2 revolutions. Now we often get a 1-to-1 resonance, as we have with our moon, where the rotation and revolution periods are equal. Perhaps because of the higher elliptical orbit, it gets a different resonance here. But that does mean that Mercury is neither the hottest nor the coldest planet in the solar system. So what do we see? How about the surface features of Mercury? Well, Mercury, we can't see the surface features from the Earth. We can see Mercury, but we cannot see the surface features. And that's because Mercury is always close to the sun in the sky. So when we see this here, here's our sun below the horizon. Mercury always being close to the sun, maybe at best a little bit above the horizon when the sun has set, or just before the sun rises. That means this is going to be bathed in the glow of morning dawn. So we're not going to be able to see very clearly. Venus being a little bit further away, we can see that as the morning or evening star. It's also a lot brighter, so it makes it easier to see. But Mercury is very difficult to see when you point a telescope that low in the sky. The sky is getting brighter and you're looking through a lot of atmosphere. It's really hard to see any kind of surface features um, from Mercury. However, we were able to visit Mercury with spacecraft. So we had the Mariner 10 in 1974 gave us our first image, and then the Messenger spacecraft gave us far more detail. Messenger spacecraft was actually orbiting around Mercury for 4 years from 2011 to 2015. Now, the first thing you might note is that Mercury looks a lot like the moon. It has some impact basins, although not as many as the moon, and it has lots and lots of craters. It is a heavily cratered surface. So overall, it does look a lot like our moon. That's why we study them together. They have some similarities, especially in terms of their surface features. However, when we look at the surface features of Mercury, we see some differences. Let's look at some of these basins. There is the Caloris Basin, which is a massive impact comparable to the larger Maria on the moon. So we do have one large impact basin, but note how many craters there are in it, and that it is not flooded smooth like the others, like other objects, like other craters that have occurred. So other impact basins on the moon. And if we look on the other side of Mercury from this, so exactly opposite, imagine drilling straight through Mercury and coming out the other side, it looks like this. Well, it's a very jumbled terrain, very unusual terrain, and likely was caused with that impact. When we impacted on one side, all those massive seismic waves traveled through and converged on the other side, completely shaking up all of the terrain there and leaving really nothing noticeable, although we do see a few craters which probably occurred later. So very large impacts that have occurred. We also see a feature that is kind of unique to Mercury, and that is the lobate scarps. So here we see one of those. The lobate scarps are kilometer high cliffs. So even though it looks like it's just a little crack in the surface, it's not. That thing could be kilometers high. And this is what happens when the planet cooled. So as the planet cooled, the inner areas cooled off, and or the outer layers cooled first, solidified, and then as the inner layers cooled, they shrank down, and the rest of the material kind of crumbled in on top of it, leading this wrinkling of the crust as the planet cooled off and solidified inside. So we can see that, and we can also figure out again what occurred first, because we can see that these go through some of the craters, meaning that the crater had to be there when this happened. If that had not, the impact had occurred later, it would have wiped out that portion of the scarp. So we can also tell, again, using the superposition, tell what occurred first when we look at objects overlying each other. Now here we can see that in a little more detail on an angled view. So we can get a little bit more idea of what's going on there. And we can see that this is a much higher in the red region and much lower down in the blue. And we can see that long cliff that goes around there. And again, that's not just a few feet or meters high, that is kilometers high. So really interesting feature that we see on Mercury there, along with, of course, a lot of craters. Now, could there be water on Mercury? Well, we would expect no atmosphere, certainly no liquid water would be possible. However, we do have some areas like on our moon where there are regions that are shielded from sunlight, and we can see them highlighted in yellow here. These are areas on Mercury that do never see the sun. So icy deposits remain here, perhaps from cometary impacts that hit in that region, and then left their material behind. And because they're shielded from the sun, they never see direct sunlight. They never get hot enough to vaporize that material. So there are some water deposits on Mercury that were detected by the Arecibo telescope looking at Mercury. Now, as I mentioned, Mercury does have a magnetic field, and a very weak magnetic field, only about 1% of Earth's. And that suggests that Mercury does have a partially liquid metallic core. So we know that part of it is liquid. And we see again here roughly what happens. A lot of the material is pushed back. It's not completely symmetrical. It's so close to the sun, and material being pushed out by the sun, it deformed. The field is deformed here on the near side of Mercury and then stretched out beyond. While Earth's is very similar. So maybe not quite to this extent, but relatively similar, as to we can see where the range of the dominance of Mercury's magnetic field is. And remember that it is much, much smaller than Earth's magnetic field. So it does not offer the protection, for example, that the Earth's magnetic field offers to us. Now, where did Mercury come from? Well, first of all, Mercury has a much larger core than expected, and it's quite possible that maybe some large impacts stripped away some of the crust in the early history of the solar system. So when we look at what should have condensed there, we would expect, while we expect Mercury to have more metallic material, it would also should have more rock than we see. So maybe some of that was stripped away by massive impacts, such as the one that formed our moon. Or maybe excess heat from the sun vaporized some of those more volatile rocks. Remember, rocks do not have the same melting point. So some of them that were more easily vaporized, these silicate rocks, could have been vaporized, leaving behind an excess of metals. Good questions and things we still study to understand on how Mercury actually formed. So what are we doing to explore Mercury? We mentioned the Messenger spacecraft that was there. There is another craft that was launched in 2018. That was Bepi Colombo. And it's a 7-year journey to Mercury. So it has used a number of gravity assist because it's very difficult to send things into the inner solar system. Why is Mercury so less explored than other objects in the inner solar system? Simply because it's hard to get there. So we used gravity assist from Earth, Venus, and Mercury to increase the craft's speed to achieve orbit. So that was required, and it's taking a long. That's why it takes so long to get there, even though Mercury is not all that far away from Earth. It has already completed assists from Earth and Venus and is now flying by Mercury, and flew by Mercury in October of 2021, June of 2022, and is scheduled, if all goes well, for orbital insertion in December of 2025. And then we'll begin to update our study of Mercury and hopefully learn more about the nearest planet to the sun. So let's go ahead and finish up with our summary. And what we've looked at this time, Mercury does have a lot of surface features that make it look like our moon, but very different interior structures. So the interior is quite different. We looked at how the rotational period and the period of revolution are synchronized together, not exactly, but in a 2/3 ratio. And we talked about lobate scarps being a feature distinctive to Mercury and likely formed when the planet shrunk. At least the crust shrunk early on in its history. So that concludes this lecture on Mercury. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.